So, well, first of all, welcome. So now we have, Stephany and I, we have the task to keep you awake after lunch. That is, almost an impossible task. We'll try. Yeah. So we also have to say, it is a tutorial. So we hope that you will learn something. But we won't have a lot of time for doing, big exercises. Yeah, it's 90 minutes, so there is not that much. And the second thing I would actually want to mention is I'm actually impressed how many are there, because our title here does not have any fancy, sexy name in there. It's not about blockchains, it's not about microservices, it's not about the cloud, all of that. It's about the real work. So not that much fun. It's work that we need to do here. So, and that's what I'm saying. I'm impressed to see you all here. So let's see what we can do. Here, our lawyer slide. Yeah, you know this already, I guess. So now, I see a lot of familiar faces. Yeah, with many of you, we actually already worked. So you kind of know me. So you probably know that we do everything that has to do with architecture. Doesn't matter where. Starting from the requirements down to the code. Wherever that is. But here in the tutorial, we are focusing on one little tiny aspect of it: the design review. Why that? Well, the obvious goal is, the purpose of the design review is, to get some feedback and saying, are we doing the right thing? Right? That's what we are doing. And I assume many of you do actually something like this, either formal or informal in some way. Can I see hands? How many of you actually do design reviews? Okay, almost everyone. Perfect. So there's nothing new. Why doing a tutorial for it? Nothing new. Now, over my, as you can see in my hair, 40 years of work, with trying to build good products. At the beginning, my picture was always, if you have the right idea, then you can do good things. Well, that's true. So meaning, if you can design a system, the right way, you will get a good product. That's all true. But if you look across, if you really want to make something happen, I actually found that having that good idea is not that important, actually. There's one thing that is way more important, is way more influential to achieve a good result, and that is actually design review. From all the tools that you have as an architect, the review, so trying to figure out, are you actually doing the right thing, is probably the most valuable from it. So that as a basis, that's one of the reasons we are talking about this. But the other reason, as you can also see in the title, it says, and we want to look at that in an incremental fashion and at scale. So starting to look at not just one project or one feature development, or however you may want to organize, you want to look across and on the enterprise level. What would that mean? Assuming that if you have not just one team, if you have 20 teams, 40 teams with, 50 applications, all in different stages of development with different technologies, some very old, some very new, to make across all of this, make everything happen. Design review is a good thing, helps you to do so. But on that scale, and in the incremental fashion, it is a challenge. So when we go through this, we'll see that from the whole process that we have, how you actually should run or could run a design review, you will see that the review portion of it is actually just a tiny little bit. And we actually won't talk too much about it because we assume you exactly know how to do that. Yeah. There are many other things around it to make it happen if you do it incrementally at scale. Yeah? So that would be the main focus here of this tutorial. Before I dive in, just a few, well, sort of like definitions. Yeah, to make clear when we use these words in that presentation, that we are absolutely clear what we mean by this. Yeah, we will talk about the architect, because the architect is the one who will actually do this. Yeah. I assume you. Yeah. Now, I grant you that if you actually talk to each other and saying, what's your job as an architect, you probably will get 20, 30 different definitions of what you actually do. I don't want to talk about what the architect's job or title is. What we will talk about in this tutorial here is about what you actually need to do, what your responsibilities are, no matter how you are called. Yeah. So one prime example is, for example, I said we look at enterprise. So immediately, probably in your head pops up enterprise architect. We have someone who is responsible for it, right? How many of you in the organization have an enterprise architect? A few. Yeah. Hopefully you are in a good organization, so the enterprise architect actually is doing what the enterprise architect is supposed to do. Yeah. Unfortunately, when we work with the organization, yes, there is an enterprise architect, but we never see him, or her. So the real work to make something happening is not working with the enterprise architect. So who is doing it? Well, at the end, you. The one who has the problem, have to do something. So keep in mind, when we say architect, we don't really mean the role, the position of an architect, the title. We mean that person who takes the responsibility to make sure that the organization is creating a good product, an appropriate product. Yeah. The other thing we need to talk about, increment. Yeah. So we are talking about design review in an incremental fashion. So therefore, the definition of an increment is important. Yeah. But every team, every organization has their own definition of what an increment is. Yeah. Design review. When we talk about review here, we do not necessarily mean something formal. It can be very informal. It can be discussion on the whiteboard. Yeah. I don't care. Yeah. It is the process where you actually check of what the solution is proposed, will it support what the organization wants. Yeah. So whatever that is. Artifacts. When we talk about artifacts, we do not mean documents. If it's document, fine, great, wonderful, super. We can work with that. Doesn't have to be. Could be a whiteboard sketch, could be code, could be anything. And then we will briefly talk about what all the possible artifacts might be that we are here. So keep an open mind that although we use those words, we do not imply anything like formal, anything written down, anything limited. Because experience shows that you will encounter anything possible. Anything you can imagine will happen. Yeah? So keep that in mind. Let me skip through this one. This is the process that we will go through when we say this design review. As you can see, that there is the topic number, the second three here, in that one. Can you see that? Oh, point is not working. Okay. Where we say, perform the software risk analysis. That's where the review actually happens. You see a lot of steps before. And those steps are in there because of the fact that we are talking about increments and the fact that we're talking about scaling, scaling up. First step would be the increment. Now that sounds very simple, but in many cases it actually isn't that simple. to define what actually is an increment that we want to do a review with, what could it be, and what's not. So the obvious things are, you have, let's say you have an existing system, the system is working, but the system has a problem. Let's say performance sucks, which requires you to actually change the design. So you may define, you have increment, and you may call it increment, or you may call it release, or you may call it next product version, or whatever you call it. But there is something that will change, which has a design change in there. If it's just staying within the design, it's just adding a new feature to it that doesn't change the design, it doesn't really make sense to do a review for that. So the assumption is something in the design has to change to accommodate something. It can be a project in the early stages. Maybe the team focused on get the UI clean. So usability is taken care of. But they didn't spend any time in the performance or the modifiability or those kind of things. And now define the next increment is saying, okay, now that we have the UI, we want to make it fast enough. So these are all the factors that go in and saying, when does it make sense to actually have something like a design review here? Just a few examples. The point here is also just be open. It can be a lot of things. But it always implies there is a design change. Okay. Next step. This is an important step. The filtering. If you're working with many teams to make certain things happen, you will have to deal with a lot of information. And very quickly, you will get to that point where you're just in the information overload. You have a lot of information, but most of that information is actually not necessary. What we found is there are only a few things that are really important, that you really need to know. Not everything. So we encounter, and I don't know how that is, in your situations, but here's, we wrote down, a typical list of stuff that we could get from a project. So things like functional requirement, UI mockups, there might be, a design document there, there might be UML model there, there might be just PowerPoint there might be, you name it. All these artifacts might be available, or none of it. That can happen too. Now, I can guarantee you, if you have any subset of these, then most of the information that you're actually looking for is somewhere in that documentation. Maybe not in that way that you would like it to be, to make your job easier. But it is probably there somewhere. And that's what the filtering is about, trying to find out from whatever the team already produced, if that is sufficient to have a successful design review in there. But be careful. I will show a few examples that people use when they explain certain things, where at the first point when you look at them, it doesn't look to you like you can actually get information out of it. But the people insist that the information is there, you just don't see it. So you have a lot of information. You need to sift through and find the places that you really need for it, which are only a few little places there here. As I said, we'll go through that. Before I go through this, just to make clear that I hope that you all have that picture. When it comes to design, the problem you solve with design is you determine what the quality attribute properties of the solution will be. Are you with me? So it is not the functions that you have to produce. It is how well those functions will actually work in the system. Yeah? So designing is about manipulating the quality attribute properties of the solution that you have. Therefore, the requirements you need for a design are the quality attribute requirements. How many of you are using quality attribute scenarios or did hear about them? Oh, okay. Well, okay, yeah, I would expect, the people I work with, yeah, sure. Yep. So quality attribute scenarios is one way to deal with the quality attribute or the non-functional requirements. It's not the only way. It's one way of those. But to do a design review, you need to have two things. Because you want to determine something like good or bad. If you want to determine good or bad, you have to have something, a yardstick that you measure against. Without a yardstick, if you look at a design, you can only say, well, it's a design. You have no idea if it's good or bad. You may have an idea if you like it or not. If you do this, then you use your own yardstick that from your own experience as a comparison, but that's not an objective yardstick. That's your yardstick. So we need to have something, and that yardstick is the quality attribute requirements. We have that, and then of course we need to have something that shows that this solution will actually fulfill those quality attribute scenarios. We call that the evidence. And the evidence is a subset of all the information that is available from the system, just a subset. So if you know what it is that you're actually looking for, you can very quickly reduce the amount of information that's available to you to a few things that you can manage. And vice versa, if you ask your team to produce something, so I'm working with you and saying, okay, so you have to solve that big performance problem. How do you do this? That's the only information that you have. Whatever he brings to me is saying, here's how I do it. That's the evidence. That's from the whole set of possible documentation, a tiny little piece of it. So we try to reduce all the unnecessary information and get back to whatever we have here. So here, just in case you never heard about quality attribute scenarios, here are 3 examples. They focus on a quality attribute, and they describe a situation, an example. So if someone comes to you and saying, I have a performance problem, you never heard about this, so probably your first question is saying, okay, tell me about it. And you ask that person to describe what the performance problem is. That person will usually describe it in saying, if I do this and this and this, then these things happen, which is a bad thing. I would like it to be something else. So the user pushes the button, and it takes 10 seconds before the answer comes back. That's a problem. It would be nice if the answer comes back in a second. What I just said is a quality attribute scenario, what we call a quality attribute scenario. So we love them because they give a concrete example. They help to focus the discussions of what to do to be able to move on and say something intelligently. As you also can see, each of those scenarios always has a number. That number is the yardstick. This is what needs to be achieved. If you don't have the number in there, you don't have a yardstick. And therefore, you cannot do a design review. If someone comes to you and saying, I have a design here, this is what I need to fulfill, it should be pretty obvious. You can see that, yes, I can actually check this. If whatever the solution is will actually fulfill those things. So, background. That is something you have to have. If you don't believe this, then the door is still open. You still can leave. But these are the basics of a software design, what you have to have. And of course, the design review is based on it. So, artifacts. So we are asking for evidence. And saying, how do you know that your solution that you just presented is a good one? How do you know that you fulfill those scenarios? So you have to produce something. This can be produced in diagrams. So many architects creating new nice diagrams. They may use a UML tool. That would be great, because that is a little bit more formal. Or they may just use PowerPoint or Visio or you name it. All of them is fine. If we have, sorry, if we have a design, something that is in a way that we can actually communicate, so we all together can look at it, and start understanding what it is and start asking questions. That is what the design diagrams are. Some teams don't do design. There are probably many there that saying, that is big overhead. We don't want that. We don't need no thinking design. We just write the code. Well, that's fine too. Because just to be honest, when people write the code without a design, the people make design decision. They design the code while they are implementing it. So there is a design. So therefore, the code is a valid design document. It may take a little bit of work to get the design out of the code, but yes, it is valid. It can be an input. It could be very, very sophisticated, so there might be existing code. You're running a performance analysis. You actually count the times that are there, that you can put on the table. Well, that would be great. If you really have real numbers on the table, you can very easily make the case why you are fast enough. And of course, it could be whiteboard. It was just a few smart people in a room on a whiteboard and saying, if we do it this way, then we will solve that problem. All of these are valid artifacts. Don't dismiss anything of those. Yes, we have preferences here, what you would like to see. But if you don't get that, at least we don't have time enough to train the teams to, for example, create UML diagrams. We just can't spend the time. It's just way too long. The learning curve is way too steep. If they don't already know it, way too steep. Whiteboard is always possible. Very quickly, very easy. So keep that always in mind. We are not focusing on something formal has to be there. So here are a few examples. So in one example, we had a portability scenario, and we asked the question, saying, okay, so how would you support the portability? And that's what the people showed us. Saying, well, so what would you say? Could you say anything about portability when you see that, even if you understand UML? Well, not directly. But now starting asking questions and saying, so, okay, why is it? They start pointing out that here, for example, VO is a virtual object. So it means there is an abstraction in there, that abstract away from what the concrete objects are. Saying, oh, okay. So every time when you have an abstraction layer, yes, of course, it supports portability. And so on. They have EJBs in there. So all abstraction level to make sure we gain independence of the platform so the portability could work. One example. We can see something like this. So this team produced code. That's the only thing they had, code. But they structured their code in a directory structure according to the architecture that they had in mind. It was never written down. We just put the code in there. But that's what the agreement that they had. There are tools that you can just put the code in there that produce structures like this. So and yes, if you have something like this, and the question is, will the code be maintainable? Then yes, you get information from it. You may have to dig a little bit deeper in there, but at least at the first, you can say, yeah, well, okay, so yeah, if you know how to read that diagram, says, yeah, there is, in general, looks good. Yeah, but there are a few issues, yeah, in that diagram. So for example, you see some red lines, yeah, in there, which are circular dependencies. And when, you probably know when it comes to maintainability, circular dependencies are never a good thing. Yeah. So indicator to drill in there. So that is when you have code. So that also means even if there is just code, you still will do a design review, not a code review, a design review. Yeah? And why would you do this? Just because of the amount of information that you have. If you try to figure out if a system can do what it's supposed to do, and when you will look at the code, at all the details, yeah, you will take a long time, you know, to figure out what's going on. Again, you have to reduce the amount of information that you have to deal with. That's why we have a design. That's why there are tools that you can use, you know, to extract the design out of it, you know, and have this and discuss on that level there. So tools, whiteboard. Yeah. Interesting thing. So the problem was performance problem. Yeah. And the people draw that picture. Again, does it say anything about performance? Well, again, not directly. Yeah. But what they mean, as you can see here, you see the word SOAP and REST in there. So there is, you know, external communication with different protocols. We know that there is network in between, so when it comes to performance, it's probably, you know, on those network connections where we have to be careful how we do this. So there is actually implicit a lot of performance information in that picture in there without really showing it. Yeah. Could have something like this, deployment diagram. Yeah. Now this is pretty obvious, you know, when it comes to security. You know, that is probably what you would ask, the first question you would ask. How does deployment look like? You know, you want to see how well, you know, the system, you know, that you're looking at is actually protected. So we will be looking like, you know, firewalls and such thing, network configuration, what's the connection and such. You know? It could be something like this, a sequence diagram with annotations in there that talk about performance. This is actually the best document, you know, if you really want to know something about performance. If you get something like this, that would be cool. Yeah? Because that really very quickly tells you, because you can just count the numbers, you know, for a sequence in there and saying, okay, do I end up with the 2 seconds that I need or not? Yeah? It could be something like this. Yeah? So real performance numbers, yeah, from an existing system. Again, I don't know in your organization, but in the organization that we are working with, all the projects are sort of like doing the similar things. Yeah? In our environment, it's a business application. So business application don't really spend too much time in computation. Yeah? So the algorithm that they have are pretty simple. Yeah? It's just move data around in some way. Yeah, do something a little bit with the data, but basically it's move data around. So there is not a lot of computation. Yeah, the performance gets lost, yeah, towards the interface, because the client is usually over a network, and it gets lost on the database, yeah, because you have to talk to the database. And if you look at that output here, it says exactly that. Yeah. The performance is lost at the database. So in the next project, you know, when they do similar things, yeah, you don't have to ask for performance numbers. Yeah, we already know this. Saying, okay, we need to know how often do you have data transfer from the client to the server, and how often do you talk to the database. That's all you need to know. Yeah? And with that, you already have the ballpark and can say yay or nay, yeah? Without looking at the details, you know, what it is. So keep in mind that the information that you're looking for comes in very different shapes and types. Yeah? Don't make the team produce information if you cannot get them already from something that is available. Here's some example about static analysis. Yeah, also one thing. It does make sense to sit down with the team before you actually do the review, yeah, because you don't really know what they have and what they don't have. To create something like what we call the evidence table here, which means saying, I go to you, your team, saying, you said in your increment here, you want to solve the modularity problem. You have this scenario here. You need to be able to change the physical data structure and not impact the business logic code. That's your scenario that you need to solve. Yeah. So if someone comes to you and saying, we pose that problem, what would you ask them that you need to produce? What information would you like to look at? Any idea? Are you shy? Shy or sleeping? Okay. So you would look for data abstractions, right? Yeah, is there something that decouples the way how something is stored, yeah, in the physical data structure, database, for example, yeah, from the business logic? Is the data that the business logic is working on, is that exactly the data that is in those database tables or not? Are there logical objects? So you look for that indirection here. So instead of just going into a review, you just talk to the people and saying, do you have something like this? Can you show that you have some data abstraction in some way? Yeah, so business object, logical objects, something that decouples the business logic from the database structures in there. Ask for it. If they say, no, we don't have anything, the only thing we have is, the database structure, so the physical data model, yeah, then you could ask then, okay, so would it make sense to create something like a logical model? Yeah, which, by the way, you would actually expect that is already there. But sometimes it's not. Yeah. So again, you remove the amount, or to reduce the amount of work that people have to do to provide the information that you can actually say, yes, that scenario will be fulfilled, or yes, or no, it won't. Yeah. Let me skip over this. Yeah, let me skip over this. So that's filtering. So the purpose of the filtering here is just sift through the amount of information that's there and identify the few pieces, it's not a lot, the few pieces, yeah, that are important that you need to know. And if you cannot find them, make the team produce the information in whatever way they choose, how they want to do this. Then assess the conditions of the artifacts. So even if you do this, so you sat down with the team, you said, this is the type of information that we need. At least we found that everyone says, yeah, oh yeah, that's easy, that's simple. Yeah, I can give you that by tomorrow. You're done. Saying, okay, by tomorrow, so that means tomorrow afternoon we do the review. Great. Well, tomorrow afternoon comes, we do the review, and we discover that the artifacts were actually not in the quality that we expected it to be. Because again, we had a certain picture in mind, that says this is what we expect, and it didn't come. So, that also meant now, review, you cannot do a review at that point. You have to have, you discussed about the artifact that you would like to see, you discussed the information that you would like to see, but you didn't get it. Or you got it in, maybe something very high level with not sufficient information. So it was a deployment diagram, but the firewalls are not in there. So we don't really know, those kind of things. So after having done lots of these reviews, we were sitting down and saying, when were we actually able to do a review? And we found out that we can be in sort of like 9 places in the space of where teams are. 9 spaces. And the happy space is where the white dot is. Now, let me give you, what that really means. So we marked a place here, the space here, yellow. The yellow space means the team has requirements, but don't really have enough information about the solution, how they actually want to fulfill this. Red means the team has a solution, but really not enough requirements, to see if, the solution is actually appropriate. And green means, okay, we have the requirements, we have the design, so it is a good place to do a design review. So by looking at all those things, all the different things that we did, we found out that there are actually only two things. Actually, it's three things, but for now, let's focus on two things. Two things that really determine where the team is. And that is the concreteness of the requirements and the concreteness of the design. Really, that's all you need to determine, can you do a review or not? Yeah? So you can be on, so you start the increment. You can be, let's say, you just have a business goal there, and saying, okay, you need to fix that performance problem. That's what the business told you. You may have, or the team may have, some idea of how to solve it. Saying, okay, so what we need to do is we need to remove reduce the chattiness of the interface, for example, as a concept. Yep. At the very high level. This is what is marked with that white dot here. At the very beginning, you are on an abstract level. You don't really have anything concrete, but you know what you need to achieve. You have some idea of how to achieve it. So that means at that point, you actually can do a design review. You can compare this thing with the thought that you have, how to solve that problem. Is there actually a pretty good chance to solve it? If you find a risk at that point, it's usually a showstopper. It's a big one. So you said, well, we need to reduce the chattiness of the interface. But let's say the data volume is actually the biggest problem. We didn't know that. Then, well, reducing the chattiness will do something, but maybe not solve the whole problem. So that would mean when you are here. What you try to do with the team is guide the team to move up those green steps until you are up in that top right level here, where you have a clear definition of what you need to do, and you have a clear idea with enough evidence to say, yes, that's what you can do. The team could be here. So this dot would mark saying, well, we have kind of like the mid-level requirements. So beside of the business goal, we also have something like, and that means that we need to think about what the data volume is, that we work with, whatever the idea might be. So more concrete, but no design idea beside of, in general, we may have to deal with the chattiness, for example. Or you could be here. That dot would mark saying, okay, you have a pretty solid design. This is what you try to do, but your requirements are not concrete, not very concrete. So you're kind of like gambling here at that point, saying, maybe we are lucky. And then, of course, we talk with those. Now, teams walk through the cube in multiple different ways. Basically, every path through those cubes that you can think of is possible, and teams actually do this. Here would be kind of like the iterative path. That's sort of like where we try to push the team towards, which more or less says, do a little bit requirement, do a little bit design, do a little bit requirement, do a little bit design. yeah, until you are at that point that it's concrete enough that you can actually say something. Yeah. So many of the Agile teams, yeah, at least try to go through these parts. And when I say do a little design, do a little bit requirements, again, I'm not talking about a month of effort. If it takes you more than, let's say, about 2 hours to get from one point to another, then the team is probably doing something wrong. Yeah? It's not a lot that need to be done. Get the requirements a little bit more clear. How long will it take you? You go to the stakeholders, you have a meeting, an hour meeting with them, and then it should be clear, right? In most cases. I mean, there are always exceptions. Yeah, I grant you that, but in most cases. Yeah? So those steps are not big tasks. Yeah? You can do that very quickly. Here's another possible path, so we call them the waterfallish thing. That means, well, get all your requirements clear, and then do the design for it. Yeah, it does work. Yeah, so you end up at the same place. Yeah. Different approach. Yeah, there are situations where that makes sense to do so. Yeah, but then, of course, the artifacts that the team produces are different from the other ones. Yeah. We have this one. Well, at first, that looks kind of like awful. Why would you go down the design path and design a solution if you don't have the requirements for it? Yeah. But actually, that is the prototype path. Yeah. You do this because, or the team does this because they don't know what the requirements are. The stakeholders cannot tell what the requirements are. Yeah. So UI is a typical thing. Yeah. So you would think that stakeholder can imagine how a wonderful UI looks like. Well, they can't in most cases. So what you do, you build a UI prototype, saying here's what you have. As soon as you can put that in front of them, then they start talking, I don't like this. I need to have something different. Yeah? So you use the design to elicit the requirements, what the requirements actually should be. Yeah? So a very valid path through the system here. Yeah? So that puts you into the position that you now should have a clear picture of what are the artifacts that you need to have that, to say something yea or nay. You know where the teams are, so are they in a place where it actually does make sense to do a review, so are they on the green line, or not? And now is the point that, If they are on the green path, that's the point where you do the review. So, but what do you do if they are not on the green path? If they're in the red or in the yellow somewhere? I assume, you as architects, you have quite some ideas of what to do. So for example, if you don't have enough requirements, so especially you don't have the quality attribute requirements, what do? Something like for the attribute workshop, go to the stakeholders, try to tease out what it is, what it's supposed to do. If you don't have enough design, what do? You have something like design session, or like something like option discussion, option workshop, or something like this, to get more information here. Yeah, so we just listed here a few. Yeah, so in case, depending on where you are, what you could do. Yeah, but the purpose of all those tasks is to strengthen the artifacts to get to that point, to that happy point in the top. So beside of doing a review, so if your goal is to make sure you can create a better product, make sure you do some of those things too, to help the team to go there. The teams might be able to just do it by themselves. You just tell them. Or sometimes you may have to help them. Sit together with the team and do those things here. So that brings me to a tiny little exercise. If you look at the work, so exercise means you have to do something now, right? Just to make sure that you know that. I expect something from you. So I talked a little bit about that cubes. That means the yellow part are you have requirements, but not the design. The red part is you have a design, but not the requirements. The green part is, you have both in an appropriate session. If you look at the work that you do in your organization, how many of you, and I would like to see hands, are actually in the green one? So in state number 2. You have what you need. Not that many. How many of you are in the yellow part? So you have requirements, but you don't really know what to do. Yeah, a few more, okay. How many of you are in the red part? Way more, okay, okay. So why is that so? Yeah, why?
Neither requirements nor design.
So if you have a job opening there, I would like to be there. That means you don't really have to do anything.
I was just going to answer your question. The reason why we have insufficient requirements is because it's hard to get our stakeholders to be engaged. And they generally don't know what they need.
That's right. That's right. And what do you do in that situation? Your job would still be, you have to make sure you put a product out there that makes the stakeholders happy.
So the way I describe it is we handhold them and we walk them through possible scenarios and just continue to ask questions to get them to lay out their best.
That's perfect. That was exactly artifact sanctioning. Yeah? You have an idea, you have a pretty good idea, I should actually be careful saying you have a pretty good assumption of what they probably mean and probably want. Yeah? You use that to come up with your own design, and then you use the knowledge about the design to guide them towards to come up with the requirements. And then hopefully you have a good match, or if not, then you adjust whatever needs to be adjusted. Yeah? That's exactly the strengthening of the artifacts. Yeah? And I assume you as an architect, you take the responsibility for making that happen, right?
Yes.
Good. Yeah? That's your job as an architect. Yeah? It's not just making sure, you did a good job. No, if something is missing, you have to fill the gaps, whatever that is. That's why you have that cube in here, that you need to navigate. Here, so actually, we talked already about this. So you said, if you don't have enough requirements, you create scenarios with them and guide them through. How many of you are actually using the functional requirements? So you probably have functional requirements, right? In many cases.
They tend to keep those and ignore the...
That's right. That's right. But one of the techniques is use them and just put the quality attribute annotation to them and saying, this is what you want to do. So how fast should it be, or how secure, or how available, or how modified, whatever the quality attribute is. Yeah, we actually found that for someone who is not familiar with quality attribute scenarios, this is actually the best way to get that information. Yeah? Just take the functional requirements, put them in front of them, and ask that question: how well should it be done? In there. So, but you could create seed scenarios. As we just said, you probably have a pretty good understanding what they actually mean, what they actually want. You could create the scenario for them, and then put it on the table, and saying, is that what you meant? Yeah? We have pretty good success with that approach. Instead of asking them, what you want, we just sit down, we write down 5 to 10 of those things, what we just make up, and just put it on the table. In most cases, so I would say 70, 80% of those, we get actually, yep, that's what it is. Maybe the numbers need to change a little bit, but that's what it is. So here also, same thing if you have insufficient design, what you can actually do with it. And here is 5 minutes overtime, not too bad. Here is, I will give you in the experienced hand of Stephany. Talk about now after we had those basics. They had those basics. Now the overarching thing.
Alrighty, so this one here. Can you hear me? sound okay? All right, good. All right, so you might have noticed that Felix was talking a lot about a cube, but actually kind of just showing you this matrix. And so where I pick up here is to tell you that the cube is actually a cube. There is actually another dimension that we are concerned with. So in addition to being sort of concerned with making sure that the requirements are concrete enough, the non-functional requirements are concrete enough, and that the design artifacts are evidence is adequate to do some kind of risk analysis, we also have to worry about another dimension, because in the context we work in, people are definitely writing code at the same time. So they're doing a little bit of design, they're doing a little bit of requirements, and they're also coding. So we also have another dimension that says, well, we need to make sure that the code actually conforms with the design. And that sounds like it just should go without saying, but the issue is a lot of times you go look at the design and it looked great when you put it down on paper or on whiteboard or in the tools, and then you look at the code and it somehow no longer resembles the design whatsoever. So that's one of the things we run into. So we actually spend a fair bit of time just making sure that we are keeping the code in alignment with the design. Do you run into that at all? Let me just ask real quick, where it just starts to diverge. And let me just ask real quick, how do you deal with that? I mean, do you guys do like code conformance checks and things like that?
We do design reviews with representatives of the implementation team.
Okay.
So they themselves tell us, architects, how do they implement it.
Okay, so they actually tell you how they should implement that. Okay, that makes sense. Anybody else do that? Anybody else go in and just check to make sure that the code conforms to the design periodically? Is that a practice? You guys haven't been doing that? I will tell you that if you tell the teams that you're going to do that, you get a lot more conformance. And if you actually do it, you will find that shockingly it starts to line up. So we actually do spend a fair bit of time doing code conformance checks as well. So this tutorial is actually about scaling up incremental design reviews. So incremental design review is a process that started a couple years ago on a small scale, saying, okay, let's take a small increment, allocate a couple quality attribute scenarios to that, and evaluate systems incrementally instead of just a big bang type of approach. And this is really sharing with you the results of having applied that method on, I think we have 14 concurrent projects that we're working right now with a small team of 3 people working part-time. And each of those projects actually have multiple teams on the project. So let's say this is one project. They have multiple teams, and then we're dealing with 14 different projects. So when we say scale, we're talking about we're having to basically watch the architecture over a whole large portfolio of projects, which are actually very diverse. They're not even all under the same management team, so it's quite diverse. So one of the tools that we have that allows us to deal with this level of magnitude of activity going on is the assessment cube, and let me talk about why that is. So it may be the case that at any point in time a team will say, hey, we're going to open up the code, we got a big design change, we need to do a design review, and we say, okay, great. Let's get you on the books to do a design review, and it never fails. We have another team says the same thing. Oh, we need one too. And we need a code analysis because we're a little bit further along. So we end up having these sprinkled all the way across in different times, and we have different teams at different points in time and in maturity of the evolution of their system. So we don't have time to dig through a ton of documents and try to understand the details of the context for every one of these increments. We have to be able to drop in pretty quickly, get our feet on the ground, and assess an architecture and tease out the risks very quickly. And so for that reason, the assessment cube is a helpful tool, because if we get down to saying, okay, all we really need is a handful of quality attributes, and then we need evidence that allows us to do risk analysis of those quality attributes, and we know that those are concrete enough to do that analysis, and the cube tells us, okay, they're both concrete enough to do that. Once we know that, then we can basically just drop in anywhere and go ahead and do that really quickly. So we're able to prepare for a design review, I think an incremental design review of fairly significant impact. Probably, I'd say, maybe it takes us, 3 hours. I mean, it's very fast. And then the actual review itself is like 2 hours. So we're able to do this very quickly. And that's one of the cube really helps us to be able to say, hey, do we have what we need to have? And if not, what do we need to get them up to the level? Do we need to do a real quick quality attribute workshop? We use these option workshops, which help us to determine where do they need to strengthen the design. And we just do those things very quickly, get them up to speed, and then we can move out. So that's the beauty of using the assessment cube. Another thing that is kind of touchy-feely, but we learned in doing this, is that we really have a collaborative approach to working with the teams. And let me step back and tell you what we did in the beginning. So in the beginning, what we did is we said, okay, we're a small team, we're part-time, so what we're going to do is we're just going to kind of use, have you ever heard this seagull metaphor? My boss back there is going to cringe. Where you come in and you kind of drop on the team some droppings, and then you kind of run away and leave them with that. We were kind of doing that. We would kind of drop somebody in, drop Felix in, myself in, or whatever, and then we would say, okay, here are the risks, and then we disappear, and then we come back to another team, and we do the same thing, then we disappear, and we said, why don't we change that approach and instead go with the approach of having the same person, the same architect guiding the team, the same teams, 3 or 4 teams for the whole year, instead of just kind of dropping different people in at different times and moving them out. And we actually thought that being able to drop ourselves in quickly and get in and out very quickly would help us with being able to manage scale. We found it actually doesn't. We are much better off if we can kind of stay with the same teams for the whole year and work kind of side by side a little bit with those teams. And one of the reasons is we can build trust. And it also allows us to kind of know what's coming down the pike on the roadmap. We understand their context, so we can actually hit the ground running a lot faster when we work with them continuously and collaboratively. So that's actually a really big enabler for us to be able to handle the scale that we do. So in terms of just a recap of the section that Felix just went through, the artifact assessment recap. So we talked about the artifact assessment cube, which helps us just to determine are the requirements, the non-functional requirements, and the design evidence adequate and concrete enough for us actually to do a productive and useful review. We talked about how that helps us with helping the teams along the way, that we can actually fill in with a quality attribute workshop or something if we feel like they need it. It also helps us a lot to know what to do next. So one of the things we ran into is actually getting ourselves confused with what do we need to do next? Like, where are they? We've got a ton of these projects. Where are they? This actually simplified quite a bit for us to be able to say, okay, well, they're shaky over here on the non-functional requirements. We're going to go ahead and shore those up, and then we know what to do very quickly. And then it also serves as sort of a pre-design review checkpoint. So before we do a design review, we actually have a really quick meeting. We look over the quality attribute scenarios. We sort of do a go, no-go kind of thing. We look over the evidence that's been provided, and if it's not going to be adequate for doing the design review, we get with the teams very quickly and help them get it to where it needs to be. So that's it really helps us. We had too many, not too many, but we had a couple design reviews where we got there and everybody thought we were all prepared, and it just was, kind of epic fail situation. So we just said, no, we use this as a quick pre-meeting check, And we just check those two things, and if we have those, if the evidence is good and the scenarios are good, then we're good to go. It sounds really simple, but it's not always so obvious that they're not ready. We practiced a little bit in an exercise, and then we talked about activities that architects can do to close the gap. So we've kind of gone a long way, so let me just kind of step back to where we are, and let me just do that using sort of my messy handwriting, and I'll call this out because I know in the back it's really hard to see. But we started with saying, okay, the first step in the process is to determine what your increment's going to be. Determine, are you going to look at a piece of the system? What feature are you going to look at? What part of the system are you going to look at? And then also, we usually allocate 2 or 3, maybe 3 to 5, it depends, quality attribute scenarios to that increment. So that's an increment. So we go ahead and we define our increment. And the next step is to go ahead and just get just enough of the right artifacts for analysis. And this is where the filtering comes in. So basically, we come in and we say, okay, you've given us all kinds of artifacts, some of them useful, some of them not so useful. But really, we just filter down and just make sure we have these 2 pieces, the scenarios and the evidence. So we're looking for the matching diagrams, our code analysis for that. That's really what we're laser focused on. And then in 3, we assess and we did our evidence mapping table, just to step back on that. So here at the evidence mapping table, this is such a handy tool, which we learned the hard way to use, but we use it pretty religiously now, which is to say, it's great that we've decided that we're going to have 3 or 5 quality attribute scenarios and some evidence, but let's work with the team and create this simple table that says, here's our quality attribute scenarios we selected for the increment, and here are the artifacts that we want as evidence. So this is where we get down to where, like Felix was saying, I want a component diagram. Not only do I want a component diagram, I want one that shows, what'd you say, encapsulation layer for portability. I want that. I want to see that. And we're that explicit with them. We go ahead and we write it down and we say, this is what you're going to provide us. Do you totally understand? And if you don't understand, we actually give them an example. So we make it so that by the time you come to the meeting, it's pretty locked and loaded. I mean, they're bringing the right thing. It still may not be the greatest design you've ever seen or whatever. That's totally fine. It's just we need to have the right artifact to be able to do the right analysis. So this is a really handy tool, and we do use that a lot. And then we talked about preparing the artifacts for review, making sure that we understand the condition. Where are the artifacts weak? Is it the scenarios that are weak? Is it the design that's weak? Where is it? Where's the weak spot? And then we talked about some artifact strengthening techniques. And of course, the quality attribute workshop is one, and the option workshop is another that we use. So now we're here to where we're about to talk a little bit about the what we actually do when we get to the design review. And this is going to be easy for you guys because a lot of you are well versed in ATAM, and this builds on ATAM. So we did want to include just a little bit about what we actually do in that step. And pretty much at that step, we take the quality attribute scenarios and we take the evidence artifacts and we kind of compare them and we kind of tease out the risks. That's what you guys are probably very familiar with. And out of that come a list of risks, and we also capture to-dos. And we find a lot of times we have really kind of sensitive architects or engineers that we're working with, and they don't like the word risk, and so we use the word to-do a lot. So it's fine, totally fine. Just to-do, think about that a little bit more, and that goes a little bit better than here's a big design risk. So we wanted to give you an example of kind of what this looks like when we're doing this comparison. And I know you guys are well versed in this, so you're probably familiar with it. The teams that we're working with, never seen anything like this, no idea. So we had to create some examples for them to explain. But basically, when we do this comparison, we take a non-functional or quality attribute requirement, like in this case, changes to the physical data structures will not impact the business logic code, okay? And then they would provide some kind of an artifact. In this case, they're providing a component diagram. And their answer to the evidence that they're providing, they basically say, well, we've got this repo layer, and that is going to insulate us from the physical layer or the physical data storage. And therefore, you're not going to have problems with changes in business logic having a ripple effect on your physical layer or vice versa. So they're able to answer the mail that way. That was this was an example that one of the teams we worked with provided. And so you can do risk analysis with this. So say, for example, and one of the examples we recently saw was actually they had business logic here and here in their design, and kind of mix match with where they were putting the business logic. So when we saw that in their design artifacts, we said, well, that's kind of a risk for a variety of reasons I won't go into, but we called that out as a risk and we captured that as a risk. So that's when we say we're doing risk analysis. That's really all we're doing. We're really pretty much just using it. I will say that we in practice, certainly take liberties with this. Once we have this artifact, it might be good to analyze this particular scenario, but 9 times out of 10, we see something else along the way that we need to kind of pull the thread on. And so it's also a way to kind of just get deep enough that you can actually do some real analysis. You don't just get thrown sort of like a software design document that's at the surface and you can't really get down to a lower level. This really allows you to get down to a lower level. So here's some design risk examples. I know you guys are probably very familiar with writing down design risks, so I won't go into these in too much time, but basically, here's our old friend, the lack of clarity around responsibilities for how developers should use modules in Spring framework that implement the model view controller pattern may result in maintainability and developer issues. So basically, if the team, this is the one I just showed you, if the team is not clear about where to put the business logic or some other logic in the Spring framework, then that causes maintainability and dependency issues. So that's an example of risk. I won't go through all these others, but the to-dos, here's an example of to-dos. So we have one project that's working with on a mobile platform that only runs on Windows. So it's not very portable, I guess you could put it that way. So we said, well, how about investigating a mobile platform that doesn't work only on Windows? So that's a to-do, because we don't want to upset that person. We're going to just call that a to-do and say, you probably should look into that. So here we are down to risk visibility dashboard capturing risk. So now we've gone through, we've done our comparison, we've come out with some risks. What do we do with our risks? A lot of times people would just put them in these documents, they float around, nobody does anything with them, people lose track of them, whatever. This is actually the most valuable, or one of the most valuable things I think we've learned. And Felix is a huge, huge player in this, is making the risks visible in a dashboard. So let's talk a little bit about that. So the whole goal of doing this risk analysis and to tease out these risks is actually to get some action done, get them fixed, ideally fixed before they turn into technical debt. So you want to get them fixed as quickly as you can. That means that you as architects have to be really proactive and heavy-handed with trying to get them fixed. So one of the strategies that we use, we have tried like stomping our feet and jumping on tables and a variety of other things, and they don't work. But when you make the data visible, it does work. And so we more and more are trying to make our risk data very visible, and it motivates a lot more action when we do that. So let me talk a little bit more about that. Before I do that, let me just mention that the architect's role in this, because you might be thinking, hey, this isn't really my job. Like, I don't really want to deal with like trying to make stuff visible and measures and stuff. I don't want to do that. But we're finding more and more that we can't have situations where the architect decides that they're going to go off for 3 weeks and fix the enterprise service bus, which is something we see all the time. We see a tendency for architects want to go down and focus again on the technology and then go off and leave the enterprise just hanging out there with project risks piling up. So we feel that actually it's more and more becoming the architect's role to actually make these risks visible and to enable the other teams to fix them. So that's sort of our philosophy. And what do we mean by making them visible? We mean making sure they're written down, making sure they're stored in a repository. We don't care what it is. It can be an Excel spreadsheet. We don't really care. That they're communicated and then monitored and viewable to encourage action. So let's talk a little bit about that. Where to put the risks. So we definitely feel like you should put project risks that you found in a project design review. Go ahead and put that in the project backlog. That makes perfect sense. It should be in the project backlog. However, when it gets to the project backlog, what happens to it against all those cool new features that the product owner wants? It's like to the bottom of the backlog. I mean, you never see it again. And so for that reason, we feel like it's great, put it in the backlog, but also keep your own backlog, your own system backlog. SAFe calls it a system backlog. But you basically keep your own. And then you can also, if you keep your own sort of backlog or repository, then you can do some neat things with it and start looking at trends and analysis for what kind of risks you're seeing, especially if you're overseeing multiple projects, the architecture for multiple projects. Let me talk just a minute about technical debt and the relationship between risks and technical debt. So how many people are familiar with the term technical debt? Okay, good, great. So one of the things that we try to be aware of is some of the risks that we come across in a design review. Some of them definitely have characteristics of accumulation. You can see how there's going to be more effort or cost down the road, more workarounds caused by some of them, and some of them not so much. I mean, some of them are kind of isolated, kind of a pain, but it's not going to get worse over time. So the ones that are technical debt, we really try to make visible. And tomorrow we have a talk about enterprise technical debt where we talk a lot about the ones where we really feel strongly or ones that we've surfaced and how we surface those when we feel like we've come across something that is a project level risk but has ecosystem enterprise implications. So we're looking for that data. So that's another reason to keep your own data and to keep and do a good job of that, because then you can come in and you can kind of see, am I seeing technical debt? And if I am, what can I do to stop it and get a handle on it? Okay, so let me talk a minute about our dashboard. So the reason I kind of color-coded this is our dashboard actually has sort of a couple different layers. The top layer is, I did in green, which is our enterprise symbol for enterprise level. And then the bottom level is the project level. So today we're really kind of just focused on this level. Tomorrow we're going to give a talk where we're going to talk about enterprise technical debt and what we're finding in this data that points to problems across the enterprise. So today we're just going to focus on this. So in our dashboard, we actually have a project design risk list, and then we have a roll-up, a couple different roll-ups that we have. So let me give you examples of those. Okay. So here's our project design risk list. Okay, pretty boring. It's basically just a list of project risks that we found in design reviews. These are all redacted from real design reviews. And then we have, obviously, we keep track of what project, which application those came from, that kind of thing. So that's pretty basic. But the power comes in is where we roll that up to kind of summarize it. And this is where we can get some action on things. So one of the views that we have that's sort of a roll-up is it basically lists the reviews that are happening for different projects down one side, and then it'll list the number of open design risks, maybe code analysis risks, we track those as well, technical debt items, and to-dos. So we can go and we can come to the PM responsible for this project and say, and imagine there's the projects. I kind of had to redact all this. So you can go to this PM and say, hey, wait, what? We still have like 7 design risks that we found in the code analysis that we did. You have bilateral dependencies or whatever. And there's been no movement. And I attend actually a meeting, a pretty high-level meeting where all the PMs are there, and I bring this up. And right before that, it gets kind of a lot of activity right before I go. Okay. So it's a very strategic, let the data speak for itself, way to actually get some action. The dashboard. So on the dashboard, it looks pretty simple, just a simple JIRA. We did it in JIRA, simple. Felix actually did a really good job on this, and the cool thing about this is it's very extensible. It actually has many-to-many relationships because we don't see our process as something that's linear or static, serial necessarily. We might do a lot of different activities, and we might kind of intersect in different ways, and we might do it for a lot of different types of projects. So we want it to be extremely flexible. So we've designed this to be that way. So basically, underneath the dashboard, we have like inheritance types relationships where you can add as many types of projects as you want. You might have an application project like application A, B, C, whatever. You might have we have projects that are runway components. Have you heard that term, runway component? Has anybody heard that? Okay, if you're familiar with Scaled Agile framework, there's the concept of a runway component, which is an architectural or an infrastructure component that you put in place that is an enabler for other teams to work more quickly. So for example, one we're working with our client right now on a secure gateway. What that does is it makes it so that they can share information from their internal environment externally in a safe way through an API very fast without having to do a bunch of crazy workaround that was going on. So basically, we have one called runway components. We have several of those, which are projects in themselves, which actually have design risks associated with them. And then, we've got one of technical debt. We also have lots of activities that we do. We do compliance checks, requirements reviews, design reviews. We also do the code analysis, so different activities. So as we do more activities, we can just add them. Risks also. We can add different kinds of risks in here. So we just tried to make it very flexible so that we can add to it. So when we document a design risk, we actually have a format we use for documenting a design risk. And this actually we kind of stole from, so I can give a plug to the technical debt book, the Managing Technical Debt book, which is out now, right, James? Is that out? Everybody buy a good book. There's a template in there for capturing technical debt items and tracking those. We kind of stole that template and are using it on this project. But we just used the first few pieces of the template to capture our design risks. So we'll capture what the problem is, what the consequence is, and the proposed solution. And the consequence actually helps us to make the case that something should be fixed. So if we can kind of put a little bit of information in there about what the consequence is, that does actually get some attention. So the problem here, this is just filling out the template. Our good old friend, lack of clarity around the responsibilities for spraying model view controller framework is causing maintainability issues. The consequences, it's going to take longer for the teams to analyze the code. If they need to make a change in the business logic, where they go, service controller, where, and so it's going to take longer for them to make changes, probably going to be more costly. And our proposed solution is, first of all, fix that if you put business logic in the wrong place. And then second, you want to make sure that you actually go in and clearly document the component responsibilities so it's really clear when the developer comes in and says, where do I put the business logic? It's extremely clear where they put that. And then also check conformance. Make sure they actually are conforming to it, which is one thing we're doing a lot right now, conformance checking. So we already said that we track the status of open risks. So we make that very visible. But not just that, you also have to, we also track where they are in that incremental design process. Good, we got just a couple more slides. Here, this is a slide, we're at 5 minutes, so this is a slide that kind of just describes, shows you a view that we show, which also gets a lot of attention. Each of these is increments, and this is actually from our real project. And we sort of color code the incremental design process here, and you can kind of see where they're getting stuck, where some teams are like not even leaving the ground, some are trucking along pretty well with the greens, some are getting stuck, and it helps us get them unstuck and get them through.
The number is.
Oh, it's just because I was color coding it. Yeah,
Oh.
it's just, sorry. But good question. Okay, last one, decision points. Okay, on the decision points, so the key point of this slide is just to say that this process doesn't run by itself. We feel like the architect has to really embrace these processes and sort of force decisions to be made, because otherwise risks just sit out there, they sit in a repository, nobody makes a decision to do anything about it, and it's really the architect that has to push them forward and be the forcing function. So today we really just talked about system architecture and identifying risks, and the architect has to be the forcing function to say, hey, that is a risk, and we're going to document that risk. And then tomorrow we're going to talk a little bit more about this piece, but it's really the architect that really makes it all work. So in summary, the goal of the design review is to produce quality software. Our incremental design process is really intended to allow us to deal with a fast-paced incremental environment and be able to very quickly sift through a lot of information and be effective quickly. We talked about techniques, including the filtering. We talked about the evidence mapping table, which is what I said, there's something you can use tomorrow. Believe it or not, we use that all the time, and it's really a very helpful thing. The assessment cube is also very helpful. That's our no-go decision tool that we use. We also talked about these techniques. We talked about quality attribute workshop, and then options workshop, and then we talked about the dashboard. So that's that. We have I think we're out of time completely. 2 minutes for questions.
Any questions?
Good.